All right, we're here today in the studio at Microcenter, and we want to do something kind of cool. I have here our electronics buyer and electronics enthusiast, Andy, and he's going to kind of walk us through a couple of simple electronics projects, and we wanted to make this into sort of a series, right?
Yeah, I think we've come a long way in the past decade or so with microcontrollers and single board computers. But I think it's always important to be able to take a look back to even the bits and bobs that make these things up. And so, yeah, with all of this stuff that we can get at Microcenter, I think it'd be good to kind of go over some of it and maybe even get started and program an LED.
Cool, I'm into it. I think for me personally, this is all very new to me. You know, like I know what Arduinos are. I know a little bit about it. I've tried to follow along with some of their like tutorials, but I just never really like followed through with that. So I kind of wanted to use this as an opportunity to sort of learn how to do some of these things.
Yeah.
And then eventually we can keep doing these and do some pretty cool stuff.
Yeah.
I was thinking I would love to build like a camera robot.
Okay.
Like a robot that you could mount a camera onto. It could maybe like move around and articulate, you know, like a pan tilt head, maybe a slider, maybe we could 3D print some of it, you know.
Yeah.
I think that's kind of like the end goal for me.
Okay. Well, we can get there, no problem, but I think we need to, in order to get there, know what we need to get there.
Right.
So I think there's some topics we'll have to cover. We'll have to talk about what it is you want to move, how heavy it is, and what kind of mechanisms or parts we're going to need to make it move.
Right.
And then really, I think the fun part comes in choosing kind of a brain. Like what are we going to program, or how are we going to design a circuit such that we can make it move? So I think probably the best place to start is maybe talking about the difference between a few of the options for the brain.
Okay. And we have a lot of brains at Microcenter.
We do. We have a lot of brains.
So walk me through. We got a bunch of stuff from the store, right? Walk me through a little bit what we're looking at, and then we can kind of get started onto a little project, right?
Right. So before we get into the brains, we're going to take a look at these pieces here on the table. And if you're a fan of the old Radio Shack where you could go in and buy resistors, capacitors, diodes, what have you, we're really excited to tell you that we're bringing that back in full force to Microcenter. And we're doing it through a brand called Electro Bytes.
I really like the name.
Thanks.
I really like that a lot. Also, I like what you did with the design here.
Yeah, thanks. Yeah, it was the goal is to make it easier for our associates to merchandise and also people to find. So all of the diodes will be red. All of the resistors will be green, although thinking about it now, it probably should have been resistors red. And anyways, but the switches will be a color. So what'll be nice about this is you'll be able to walk into a store and see a rainbow of sorts and know that, okay, if I'm on this, all this color will be diodes.
Right.
Or all this color will be capacitors. So our goal is to help people be able to find stuff way easier themselves, but also help the associates know where to go quickly. So,
and if you're working on any projects at home, it'll make your life easier when you come shopping, right? Because I worked at a Radio Shack like almost 20 years ago when I was in college. And I remember those shelves and all the it was actually kind of a pain putting everything in there. And it was a pain finding things.
Right.
That I feel like this is actually kind of a really nice, elegant solution to help people out across the board. And we got a lot of cool things here. And this is just a little sample, right? Because this is going to end up being a whole wall of different electronic components.
There'll be till it's all said and done, there'll probably be hundreds of SKUs between how many different diodes we carry, integrated chips like a 555 timer. The other thing we did too was we tried to make the text really clear, but then on the back we gave you a little about document or about paragraph to say, hey, here's what a diode does, just at a very high level. So they're somewhat educational at the same time. But yeah, we're excited to get these in the stores here in the next few weeks. So keep an eye out at your local Microcenter for those.
Cool. All right, so let's dive in. We were talking about brains What are we looking at, right? When we talk about brains for different electronic components.
Well, let's get rid of this stuff, right?
Yeah, I'll put this on the side. This is going to be a nice, messy work area.
So we've got a few things when it comes to brains. This is an official Arduino Uno.
There we go.
So let's talk about it in terms of maybe simplest to not simplest. I don't have the one thing I kind of wanted here because I can't find my 555 timer chip. But at the very base of everything, using something like a 555 timer, using something like the 555 integrated circuit, or often referred to as IC, that can be a brain by itself in a sense because you're providing it different input voltages to make it turn something on and off at any frequency. So, but the point of that is kind of to say that we can go from sort of a component level.
There's a lot of components.
Yeah, none of which in this case are smart, let's say, like an integrated circuit. We've got resistors, LEDs, and some jumper cables. We've got a couple of capacitors. We've got a couple of buttons, clicky buttons. And we'll talk through all that. But so with this, you could set up a circuit very easily to have a button press an LED turn on, right?
Okay.
So that's a thing. Now, if we want to control that either in repetition or through a loop, we could step up to something like an Arduino Uno. So now the Arduino Uno has been out for...
It's been a while.
Right. I want to say maybe 8 years or more. I was back in 2013 using one called the Arduino Due Milanova. It's all Italian because it's where it's from. And that was really cool. It was my first step into programmable microcontrollers. And I remember back in the day at Radio Shack, you could go buy a PIC controller, and the whole set was like $100, and it came with this board and some LEDs, kind of like that. When the Arduinos came down to something in the neighborhood of $30 to $40, and then now you can pick something up at a microcenter for under $10, things got interesting, right? Because now you could put it in anything and it would be affordable. So for this, we're going to connect it using USB to program it from a laptop. And then we're going to connect some things up to it, and we'll use the breadboard, I think, just for the fun of it. And that would be basically inputs and outputs. An input is something like a button press or a temperature. Or let's say an ultrasonic distance sensor that knows,
like those two little like cylinder looking things.
Yeah, like eyes that you see on a lot of hobby robots. And what that does is it pings out a signal and waits for it to come back to sense how far something is, like echolocation.
Okay, that'll be cool.
So those are inputs, and then your output could be an LED, it could be a motor, it could be a little display. So any number of things. So what the Arduino is really good for is writing the code that says, if I receive this input, whatever it is, temperature or a button press, do something to my output, do something to my screen. So if we go to your idea for the camera rig, the idea is that you might want to have a button that does a certain macro, or does a certain movement. So rotate here across time and go up. So the input would be the button, or if you got really fancy, you could build a web page that talked to the microcontroller that we have.
Which I think we would want to do.
Yeah. And then set into play a pre-recorded script, so to speak, or a pre-recorded path that the camera would follow. So your input's the button, your output is the motors, motors plural, because you probably want to do a cool shot where it's moving and rotating at the same time.
Like an X, a Y, and a Z axis all working together.
So that's what an Arduino is good for. It's good for taking inputs and doing something to an output based on whatever that input is or whatever you tell it to do. I think today our main goal is to get this to blink an LED, and while that is very basic in some regards. I think what we're going to see is just through the path of doing it, we're going to better understand how to get started.
Right. Cool. I'm into it. But then what's this guy over here?
Well, so we went from components to a microcontroller on an integrated circuit. This is your integrated circuit chip here. The good old, let's see, Atmel 328PU. Yes. Atmel 328PU. And then this is a Raspberry Pi 5 with the active cooler installed. And on the bottom, we've added a Pimeroni NVMe based Duo so that we can put two 1 terabyte inland SSD sticks on it in order to make a RAID array open source NAS.
And this is a full-on computer.
Yep.
Right.
Yeah, so a Raspberry Pi is an SBC, which stands for single board computer.
Right.
It's all on there, the processor, the RAM, the North Bridge, the South Bridge, however they refer to that. The power handling is all on there. Your power supply is separate. It's a wall-wart style thing. But yeah, it's a full-fledged computer that can run Linux, a full operating system.
Right.
And in fact, at the point of the Raspberry Pi 4 and then Pi 5, we also have dual monitor out. So you can actually run 4K at 60 frames per second on 2 monitors with the Pi 5.
Right. That's cool. So in terms of projects and scaling projects, right? Like, and this is my basic understanding because I've tinkered with Arduinos a little bit.
Yep.
This is basically taking sort of analog signals, making them digital, has some code in the chip that executes those analog signals, and that's it. There's no operating system. There's no nothing else.
Yeah.
You just inject the code into it. This is just a full-on computer.
Yep.
So it can just do everything that a computer can do, basically. Operating system, all of that. And in terms of projects, right, they kind of do they have two different purposes, right?
Yes. So there's
overlap.
Yeah, there's definitely overlap. So the Arduino itself is good for something that you just need to put in and have it do kind of like mindlessly, right? You don't need it to go out to websites per se and check data or et cetera. Now there are plenty of microcontrollers that now have, or for a long time have had a Wi-Fi chip built into them, like the ESP32 boards that we sell. So that's kind of sits in between here, which we don't have one to show you. But the cool thing about the Raspberry Pi is that it also does have these GPIO pins. GPIO standing for general purpose input and output. So again, all of those things I was describing to do here, click a button and have it turn a motor, you can also do with the Raspberry Pi through these general purpose input output pins.
Okay, cool.
Yeah.
And then you can also just put 2 terabytes of storage if you really want.
Or more. Right?
Which is crazy.
Yeah.
It's such a small package. Like, look at this.
Yep. I mean, for me, it's that project is how portable can I make a 2 terabyte NAS? And it's, why would you? You want it to be somewhere safe. You don't want to take it with you everywhere. But if you did. But
you could.
Yeah.
All right. So let's dive in then. Let's look at some of the stuff here. Let's make some space. Where do we start?
Let's talk a little bit about what's on the Arduino board itself so that we're familiar with its topography. So let's dive in a little bit. Things that you might be familiar with are the USB port. It's your old, help me out here, is that USB-A?
USB B?
USB-B?
I think it's B. It's the big one. I forget if it's...
I think you're right. I think it's USB-B. A is the other side.
Because it's A to B.
Yep.
And then there's like micro, mini. There's so many different USBs.
I just wanted to prove that I don't know everything.
Yeah.
That's one of them. And then you have a barrel jack, right, where you can take, I think it's 9 to 12 volts. On that note of the barrel jack, let's talk power for a second with all these things.
Right.
This board can operate on the 5 volts that you get over USB-C. I'm sorry, USB-B. There are versions that have the USB-C header on them now, which is nice because I like everything USB-C if possible.
Right.
But the board can operate on that 5 volts of power, either from the USB, 9 to 12 volts from the barrel jack, or you can actually, on some of the pins that are labeled, you can actually put voltage in, VIN I think is what it
Right.
says there.
Yep.
So you can put 5 volts in there and there's your ground. So if you're coming off of a circuit board like this, or I'm sorry, a breadboard like this, and you've already got a 5-volt rail, let's say, and we'll show you that in a minute, you could take 2 leads off of here to power your Arduino instead of a USB cable or wallboard. So if you need to share power, you can do that, assuming you have enough amperage. And amperage is just, it's not the voltage, but it's how much throughput do I have? Can I actually power 5 devices, or do I only have enough bandwidth to power 2 or 3 devices? So we'll find out that kind of stuff way later on as we build things out. So you've got your power. This little bit here is kind of power handling, which allows it to take that 5 to 12 volts, or the 9 to 12 volts. And then these 2 black rails here are your input and output pins and power. Everything on this side is digital, meaning 1s and 0s. Everything on this side is not digital. These here are analogs.
Okay.
And what that means is it can read a voltage, let's say, from 0 to 256. Is that right, or is that light? 127's MIDI. There's, I think it's 0 to 256. I'll have to check that.
We'll fact check this one.
We'll fact check that. This is, again, proves that I don't know nearly as much as I should to be able to do these videos. But yeah, it takes a voltage in and can convert that to a digital, so ADC, analog digital converter. And then these right here are a lot of your power handling, including a reset pin so that you can restart it. Now the board itself does have a reset pin on it. And then it's got these other connectors here, which honestly I think I've used maybe once. Yeah, don't really use those. Some people do for debugging or what have you. But here's the star of the show, as they would say on Lady Adafruit's channel. This is the Atmel 328 PU. I think it's 16 by 2 chip. So if you really wanted to build a final project that went to market, you could theoretically skip all of this other stuff and just have this chip on a breadboard or a circuit board and take your cost way down.
Interesting.
Now,
Okay.
there are some components that you kind of need to go along with this just to keep it regulated in terms of power, and then also clock speed. So you have I think it's a 16 megahertz crystal oscillator here that helps keep this thing running at a constant speed.
Crystal, like quartz crystal?
Yeah.
Or like, okay.
Yep. Like kind of what would be in an old quartz watch.
Right.
Yeah. And then somewhere on this board, we're going to find it pretty quick. There's any number of LEDs that are going to help us get started, just to make sure that everything's working the way it is. So that's kind of the topography of the board. All right, so on our computer, we are going to open up the Arduino IDE. What are we going to do? We're going to make a LED blink.
I was thinking, I want to try a couple of things, right?
Okay.
Because I know that you can have the LED blink, and then I thought it would be kind of cool, since we have alternating colors or something. Maybe we can try to alternate between them, either with button presses, or maybe have it like run in a series, like where they blink in a series, and we can lay them out that way.
Yep.
I don't know, something like that.
Yeah, we've got enough parts, and I think we'll find that it's relatively easier than expected once we get going. App Cloud Editor, so it's app.arduino.cc.
Right, okay.
There we go. And we're gonna log in.
Nice.
This is,
So those are all of your projects?
yeah, over, let's see what time period. 2017, but there's stuff that goes back further. Oh, 2017 was like when I first uploaded it to the cloud. There's 2025. At one point, I was trying to make a electronic cuckoo bird clock. I did make a robotic T-steeper, which was neat, just a servo going up and down attached to an arm.
I remember that one. That one was kind of fun.
Yeah.
You gave me a live demo of that one.
And then any number of other things. Holy cow. So what we'll do is we'll go create over here. We're going to do a new sketch. Yep, okay.
So here's my question.
Yep.
Right. you're getting the digital part of this kind of setup, right? The coding part, but getting into this, because I bought one of these kits like several years ago, and I really thought it was as simple as sort of like plugging some things together, wiring some transistors, and you just kind of go. But the digital part kind of lost me with all of the coding. Do you have to learn coding just to get into this? Is it necessary?
It's not. You don't. So let me say this. When I started, I was very intimidated by the aspect of coding. Now, I had come from learning HTML when I was very young, like writing web pages at the very raw notepad state.
Right.
So I understood coding as much as that. I tried to do some JavaScript over the years and was okay at it, got certain things to do what I wanted it to do. I think the important thing to know, like if there was one takeaway from all of this, is that there's no, and just like with art, there's no like, I mean, there are, but it's very rare at this point. There's no like aha moments. There's no like, I'm going to write something completely from scratch anymore. I mean, for the most part. So in terms of knowing coding, no, because what you're going to find are a lot of examples out there. 7.38 times out of 10, somebody's already going to have done a project that is very similar to yours, if not exactly the same.
Right.
So first thing I usually do if I'm teaching people about Arduino is I get them to blink a light, and then I say, look, you're a programmer now. Like, you've programmed a thing to do a thing.
Right.
You're technically a programmer. Don't make it any more difficult than that.
Okay.
You've got to look it up. You've got to look it up and figure out how to do it. And you've got to learn, just like with any skill that you acquire. But don't think that you have to be able to write 100 lines of code from memory or from scratch to be able to do this. You don't.
Well, today I'm going to become a programmer.
That's correct. That's correct. So let's go ahead. Let me grab the cable for this. So I'm using the Arduino Uno out of the Arduino Student Kit, which we sell at Microcenter. And I pulled that out ahead of time. Let's see if we can find the U-sub cable.
There's all kinds of goodies in here. I like the boxes too.
Yeah, those are pretty nice. All right, we are going to hook this old-fashioned USB-A style to B style cable up to our laptop, which still has this port on it. And nothing should light on fire. Good.
Yep, I heard the beep.
Yep.
You got a good connection.
Yeah, and I'm not sure how quickly it'll show up on the screen. It did give me a notification that it didn't see the utility. So in order to operate these Arduinos, where we're going to program them over a universal serial bus, USB, serial being the key word in there, we need what's called a cloud agent. And what that allows the web to do is talk serial through the USB. So it allows your web page to utilize a serial protocol to send the code.
Okay.
So I'm downloading it. So we're going to install this, and then it says check for this little icon in the system tray. If I go to my system tray, I don't see that yet. So let's go ahead and make sure it's installed. Set up the Arduino Cloud Agent, user agreement. I'm sure it's all good and dandy.
We're going to agree to everything.
Yep. What is it? All our bases can has be cheeseburger yours?
That's like every 2000s meme just thrown together into one. All your base are belong to us.
Yeah, that's it. Ken has Ermagerd.
Yep.
All right, your agent is ready. You can now close this tab. Let's see if it's down here yet. Are you down there? I think that's you. There it is. There's your agent. Okay, so let's go back to our sketch. And now that we have that up, it sees it on port COM34. Now, the COM34 thing is kind of important to know. More historically, just because when you used to connect things to like an old personal digital assistant like a Palm Pilot you would hook at your computer, you would have to go in the settings and tell it which port it was connected to. At some point that became more automatic and obfuscated by the software and the human user interface. But sometimes when you're using Arduinos, you have to like find that. Luckily this self-detected it. We go in there. It now shows up here that the Arduino Uno is connected.
Got it.
So I have a good connection. I mean, now I'm ready to write code. I'm ready to send it to the board, and I'm ready to program. So
where do you want to start? Do you want to start with assembly? Do you want to start with coding? Where do we start from here?
we're going to send the most basic program to the board, the hello world of electronics, microcontrollers and electronics, which is called a blink sketch. We're going to make an LED blink.
Okay.
The nice thing about the Arduino is it has some LEDs built in, so that we can actually do something on the board without having to connect anything just yet.
Oh, really? Okay.
Yep.
So hold on. Let me back up 2 seconds because you said there's LEDs on the board itself.
Yes.
I knew that, but I also didn't know that you could just program it straight to the board, because I remember doing this and actually struggling with the pins on the breadboard for the first time.
Yeah.
I didn't realize that it was actually that simple.
Yeah.
So that's actually kind of nice.
So, and that's the cool thing, like back in the day, like if you were just buying a programmable chip like this and you had a programmer and all this stuff, yeah, you'd have to wire everything up. You'd have to probably even wire in the, this guy here, which I told you was...
the crystal.
Yeah, thanks. I forgot.
It's the crystal.
The crystal oscillator.
It makes it sound more magical than it is.
Right? Something like, what was it? Jim Henson's The Dark Crystal?
Yeah.
So there are LEDs to show that it's on. Where did my handy dandy pointer go? LEDs to show that it's on. There are LEDs here to show that it's receiving or transmitting data, which we'll see in just a minute.
So RxTX, I see that.
Yep.
Okay.
RxTX over serial. And then here, this one that's already blinking it's like kind of giving away the end of the movie already, because
Right.
it's doing what we're going to have it do. But we're going to modify that. So hopefully you can see that on the camera.
Yeah,
It's
the L.
not horribly bright. Normally what this is tied to, this LED, is tied to pin 13 right here, I think.
There
One
you
of
go.
these two.
No, yep, top one. Yeah, you got it.
This one?
Yep. Number
13. And then luckily we have ground right here too, so we'll make use of that here shortly. Actually, let's go ahead and do something. Let's take one of the LEDs that's sitting there, red, green, blue, whatever you want,
Okay.
and let's plug it into 13 and ground. Ask me a question.
Does it matter which end is which? Because I know one is longer than the other.
That is correct, yes.
Right.
The polarity of that component does matter.
Got it.
So the shorter leg is ground.
Okay. And the longer leg is going to go into 13. Shorter leg goes into the ground.
Correct.
So I can just plug it right in.
Yep.
Just try to get it. Oh, hey.
Yeah.
Oh, that was actually surprisingly easy.
Yeah, you're just duplicating it.
Right. So it's the same signal. It's just
Yep.
catching on that one now.
Yep. And the point of this is to say you've got a built-in test to prove that something's working. You've got a test to say that you're connecting something right to these headers
Right.
before you even have to go to a breadboard and connect up a bunch of wires, which we'll do here in a minute. Now, I don't know, and there's probably somebody that's going to say, oh, you can't just plug a LED directly into the pins. It'll burn it out. They're only supposed to take 3 volts or something like this, and you're giving it 5 volts on and off. That's correct.
Yeah.
But for the point of this, it's fine. And if we blow up a blue LED, we blow up a blue LED.
Well, fortunately, we have plenty more.
I think we do, yeah. So yeah, we've got that blue LED now in pin 13 and ground directly. That's convenient that they put a ground right there. If we needed to, we could, bend out the pins and stretch it to another pin relatively nearby.
Right.
But yeah, so we've got that going on. I think what we want to do is we see it blinking at about once per second, on and off per second. So let's look at what that code would actually look like. If I go into here and I go to examples, you have any number of things we can try. This is where it's really nice. They built in, and I mean this is it from the start. They might not have had all of these examples from the start, but Arduino, the idea was we're going to give you a development environment that has the basics built in, so you can just pull them in real quick.
Right.
If I click on Blink, I don't know that I need to double click, but let's go back over here. There you go. You got your code. Everything that's kind of grayed out like this with these 2 slashes here, or with a slash and a star, are comments. So they don't actually affect anything. I could write.
So it ignores that.
Yeah, microcenter in here, and
it has no effect on the code.
Yeah, it has no effect on the code.
So that's like an ignore command. Well,
Yep.
It looks like there's a start and a stop. It's slash star star slash.
Right. If you want to
Okay.
do multiple lines, if you're just doing a single line, it's just slash slash.
Got it. Oh, I see.
Yep.
Okay, ignore that one line. Got it.
All right. So rather than get into right now, and that's it. That's all the code to blink an LED. That's it. Rather than get into that, we're going to make a change somewhere and see if it works. So right now it's doing this loop that says LED built in on 13, make it high. The next line says wait for a second, 1,000 milliseconds, and then LED built in low, wait for a second, delay another 1,000 milliseconds.
Interesting. Okay.
So what could we do initially to prove that we sent some code if it's already doing this?
I guess let's make it blink faster. Do like
Yep.
try like 250 milliseconds just
Great.
to make it more rapid, right? Because that's going to
Yep.
give you 4 blinks per second, or no, 2 blinks per second, because it's alternating. 250, 250, 250,
Correct.
250, right? So
Correct.
that's 2 blinks per second. See, I know a couple of things.
Yeah, that's pretty good.
I could do some math.
All right, so we just modified the code ever so slightly,
Right.
just these 2 values. And we are going to, we can either verify the code, make sure that the integrated development environment says, yeah, that looks right.
Right.
Let's try that.
And so it runs through the code just to see if
Yep.
it's like working, everything's all copacetic.
Yeah, let me do that again just because, well, it's going to do it again regardless. Down here, it'll show you what it's doing, like if it's how many % of the storage space it's using. So there's a total of 32,256 bytes of memory on this chip, and it's using 2% of it.
922 bytes. And that's on this chip itself, right? All of that
Yes.
is being injected here onto that memory. And
Yep.
Got it. Okay.
And okay, so let's go ahead and send it using this arrow, this upload tool. Console verifying.
So now it's sending
Uploaded.
it over the USB. Oh, there we go.
What you saw there was the transmission and the interruption of the program.
Yep.
But now it's blinking as you would expect. I didn't keep my eyes on it, but let's do it again with different values, and keep an eye on the RX and TX LEDs to see if they do anything.
Okay.
Right? I think we'll do something else with that too here in a minute. I'm going to change it to... Okay, camera guy. What could we do? How fast could we make it go to make it look like it's not actually moving?
Oh, I don't know. Try like... What are we shooting? We're shooting 60 frames per second. I don't know what the shutter speed of this thing is set to. You know what? Actually, you're probably going to catch it anyway, because these cameras are getting really good at like ignoring to sync up to any refresh rate in lights, like fluorescent lights or other lights. They like automatically kind of like adjust their shutter angle and like all this other refresh rate stuff to like catch it.
Let's do 60 and just see what happens. It'll
Yeah,
probably
60
just
milliseconds.
look like it's on all the time. But for this purpose, we're looking to watch these 2 surface mount LEDs down here.
All right, so you're injecting it now. Oh, there it is. I saw it. Yep.
There they go. It was receiving.
Recede, transmit. I was blinking really fast.
Oh yeah, that's nothing.
That almost gives me a headache. Like
Yep. Keep looking at it. I'm gonna try one more just for fun.
10 milliseconds.
Yeah. Let's see what happens.
All right, so it's verifying, loading.
Yep. Get rid of this little window so you can see what's going on more down here.
Mm-hmm. Then receiving, transmitting, 10 milliseconds. So it just looks like it's on.
Right, but it's actually blinking really, really fast.
Right. Interesting.
Now, let me see if I can find out. These are digital pins, so they're ones and zeros, right? Some of these pins are called PWM pins or pulse width modulation pins, and you can tell that which one is which by the little tilde.
Okay.
So, I think the MacBooks do it still, but like, and a lot of laptops do it now, where when it's charging, it pulses in and out. It gives like a breathing effect. All that is ramping up and down, on and off,
right,
to make it look like it's brighter or less bright, depending on how fast it's going. So we've done the basic blink. We've got it working. It's blinking so fast we can't even see it now.
Right.
Let's try a fade. Let's look at what the fade code looks like. Still sees our board.
So it's funny, I'm looking at the laptop here, and this is like in my peripheral vision. I'm specifically trying to not look at it, and I can see it flickering in my peripheral.
Oh, okay. Yeah, that's crazy.
You ever buy like the LED Christmas lights?
Yeah.
I hate those lights so much because they flicker a lot. And
Yes.
they give me they make me feel nauseous almost. So I always stick with the incandescent little bulbs.
Yeah, they're classic.
Yeah, I don't know. Sometimes LEDs, they flicker just so much. Like you can just tell in your peripheral. It drives me nuts. This is driving me nuts.
You can, well, especially with an RGB LED, you'll start to see the colors separate too, depending on where you're at. So this is the fade sketch.
Okay.
I wonder what this does. Oh, look at that. They even give you how to hook it up to a breadboard now.
Oh, wow.
That's
so
fantastic.
Full-on diagram. Okay.
Yep. So if you wanted to do that, see how they're putting a resistor in between the LED and the board because it's giving it 5 volts and we want to take it down to 3 volts using a resistor. We'll get to that later. That's fancy stuff. They give you a picture of the schematic. So this is the chip and all the pinouts on the chip. If we went back to the Blink sketch and they had this, you would see this on D13. Now what they want us to do is plug it into D9 because D13 is not a pulse width modulation compatible pin, but D9 is.
Okay.
So let's go ahead and take the LED out of the board and do this layout.
A little bit of heat on this LED. A little bit warm. All right, so this layout here.
Yep.
Okay. So walk me through a little bit, all right?
Okay.
Like, first of all, historically, breadboards literally were just wooden boards, right? That they would just put wires on. That's
Yeah,
like,
they would screw like screws in, and they would wrap the wires around the screws to connect the circuit. So we're going to take what are known as male-to-male jumpers.
And that's going to be this, right? Pin to pin.
Pin to pin. And we're going to start at the 9 pin on the Arduino.
And that's going to be this pin right over here.
Yep.
And that just kind of goes just right in.
Yep. And then we're going to come over to one of the rows on the breadboard, and I'll tell you about how the breadboard is connected.
Does the row matter?
Not for this purpose.
Okay.
So pick any row you want, but it's worth noting that, and I'll use my little
I'll do row 17.
cursor over here to show anything on the row will be connected to itself. So for instance, where that blue is coming in, we're taking this resistor here and it's going to touch it. So let's find a resistor.
Are all of these the same resistors?
They are not, and that's for another episode.
Oh, how do I tell which one's which then?
Right?
Oh wait, I see the little markings on them.
Yeah,
is that a hint?
Yeah, there's bands on them. I'm gonna go ahead and say that are any of them that different? They didn't write it on these. Sometimes they'll write it on the if it's 220 or 330. I think for the sake of what we're going to do, let's just take this random one that's hanging off there. I think we're probably fine. The worst case scenario is it'll be dimmer than we expect. And honestly, for what we're doing, we don't absolutely have to have one, but it's proper.
All right, so I'm taking the ends, bending them down.
Yep.
So I want one end to go into the same row.
Correct.
Right, so I picked row 17.
Yep. Does it matter which end?
Oh, that's a good question.
No.
No? Oh, okay.
These resistors the polarity does not matter.
Okay, so it's
It could be
bidirectional.
either way. Yep.
But there are some transistors or resistors where, like, it does have a polarity.
That's a good question. I mean, there's, I don't know.
We'll find out.
See, I'm an enthusiast, not an expert.
Well,
I can't think of one right off the top of my head.
We'll find out things together as we go along, right?
So we're going to plug in that resistor, and you're right. We're going to plug it into one lead into 17, and one lead into, I don't know, a handful away.
Just to make it easy on myself, it looks like it reaches into 10.
Okay.
So I'll just do 10.
Okay.
Right?
Yep. And what we have coming off of 9 is a positive signal.
Okay.
So we're now going to grab whatever LED we want.
Let's go. I'm going to keep it blue because microcenter blue.
Yeah. And since this is a positive signal, we want to use the positive lead of the LED, which is the...
Longer lead?
Yep.
Got it.
You got it.
So I want that to go into row 10.
Correct.
And the other one...
Can go right beside it in row
Oh, like row 9 or something?
Yep.
Got it. Okay. And the distance doesn't really matter. I don't have to put them right next to each other. I can space it out.
Yeah, you can. You absolutely can. But they have to be in the same row. So is your...
No, not at all. I was looking at it. You're right. I was looking at the wrong angle. There we go. So now it's in row 9.
So let's recap quick. You have the positive signal from 9
Right.
coming out, going through the resistor to the positive leg of the LED. Now we need to connect the negative leg to ground. So let's talk about the breadboard in terms of how the electricity flows. In this center part, the A through J, everything flows up and down these rows. In the positive and negative legs, it flows up and down. So everything on this red line will be positive
Right.
once we hook it up that way, and everything on the blue line will be negative once we hook it up that way.
Left to right on the rows, up and down on the columns.
Yep.
Yep. Okay.
Yep.
And so I've got to get 9 to the negative rail. Is that where we're going? It looks like that's where we're going now.
Correct. Yeah, we could technically skip this whole thing and go straight from 9 to a ground pin over here, like what was next to 13.
Right.
And I think that's what we'll do. The reason they would want to hook these up is if you have to pull power for different parts of a circuit that you're breadboarding.
Yeah, I see. So I think if I understand the diagram
Yep.
right, you're basically powering both rails on the side.
Yep.
So that you could just keep reusing that and then change out the core components.
Yep.
Right. Okay.
And in this circuit specifically, the 5 volt is unnecessary because it gets terminated here.
And
Nothing
you're not
is
using
plugged into it except for an extension up to the top. So the LED is getting its positive from the pin 9. It's not getting it from the 5 volts.
Got it. Okay. All right. I think I'm catching on here.
Yeah,
so
yeah.
we could just bypass that completely.
Yep.
I'm going to put this into row 9. And then put the other end straight into the ground.
There's so many grounds, and they all touch.
Are they all the same?
Yep. Ground is
Because I see
ground.
there's ground on this side, there's ground on that side, so it
You
doesn't
could
matter.
do either one.
Okay, so I'll just reach it over to this side again. So I put it on the same side as here.
Okay. You've wired up the circuit.
Cool.
That doesn't make you an electrical engineer, unfortunately. not like hitting programs. You're a programmer.
Being a programmer is easier than being an electrical engineer. That's shocking. You can't AI.
I won't say either of those things.
You can't AI your way through laying down cable, right?
So we've done the layout. Let's see what the fade tech demonstrate. Oh, thanks. That could have been in the comments, which it is. So let's talk a little bit about this code. Let me see if I can...
So this is longer because the other code,
Yep.
I counted, it was about 13 lines of code. This looks to be about almost 20.
40. Well, if you don't include the... Correct. If you don't include
16
the
to
comments.
40. Yeah.
So the first thing we're going to do is we're going to tell it which LED we're using. The initial brightness we're going to set to 0. The initial fade amount we're going to set to 5. How many points to fade the LED by? Like how fast does it fade? And then we're going to do what's typical is a setup section, And all we're doing is we're going to say that the pin mode for LED, which refers up to here, the pin mode for 9, so it's just claiming a variable down here to LED, is going to be an output. That's what we're going to use it. We were talking about inputs and outputs earlier. This is an output.
Okay.
Now, here's the part where it actually runs the code. So this is void loop, and then analog write, LED. So on pin 9, analog write, the brightness, which brightness starts at 0. If brightness equals, or if brightness, or not if, there's no if per se, it's brightness equals bright plus fade amount. Here's your if statement. If brightness is less than or equal to 0, brightness, or I think that's what those guys are, or brightness is greater than or equal to 255, fade amount equals negative fade amount. So what this is basically doing is reversing the direction, just as it says here, at the ends of the fade.
Okay.
So it fades up,
It'll go up,
fades down, fades up, fades down.
Got it.
And then for 30 milliseconds to see the dimming effect. So we were down at what, 10 milliseconds when we did the blink, and we couldn't detect it. So 30 is going to be similar. It's going to be, it should be a smooth fade, basically.
Got it. Okay.
I think that's all we have to do, and we're ready. This is still connected.
And there's nothing we have to do for the pin, right? Do we have to say like which pin is it going to? Is it just sending a signal out in general? Or
So that's what it did. It initialized
so it knows
9.
Because does it know that there's a signal going through? Is that why it initialized 9, or did we type that in?
This would have been typed in. This was part of the example code. For instance, if we wanted to put it on 6, we would just have to move it to 6.
Right. We were following the diagram, so that was preset. Got it.
Yep.
Got it.
Yeah, you're right. We could change that. If we changed it to 13, it wouldn't work because 13 is not a PWM pin. And even the code up here kind of restates a lot of that stuff we just talked about in terms of the tilde sign being on the board.
Okay.
But to see what it does now, we will go ahead and skip verification and go to send or upload. And let's get rid of that.
So now here's the fun part. Here's where we get to find out if I actually plugged everything in properly.
Right.
Which I think I did. Yep, I see it's receiving. And oh, there it goes.
Yep.
All right, so it's up, there we go. And there's the fade.
Yep.
So then it's going up, peak power, and then it's going down, 0 power. Up, peak power, up, 0 power.
For the heck of it, let's remove the resistor from the circuit and plug the lead right into the channel, or to 10.
So this?
Yep. Let's just go ahead and, you don't even have to pull the resistor out, just plug that right into 10. What should happen is it should get a bit brighter.
Whoa, that is brighter.
Let me see.
That's noticeably brighter.
Yep.
Because it's shown right in my eye.
Yep.
Because I was looking right into the LED. So hold on, I can do, because it's just sending the signal. Yep, so that's dimmer, and that's the work of the transistor.
The resistor.
Or, sorry, resistor.
We'll both learn what transistors are later.
Transistors are very different, right?
They like make things switch on and off and allow for amplification and all kinds of fun stuff.
So I just want to see, because now I'm feeling experimental. I'm feeling confident.
Yeah, good.
I have a different resistor. I'm just going to rip this out and just run this from here to our positive lead and see if there's a difference in brightness.
I think that's less resistive, meaning it's letting more electricity through.
It seems a little bit brighter.
Right.
I mean, I don't have a light meter on me. I didn't really measure it, but it seems brighter from what I can tell.
Yeah, and maybe in the next video or an upcoming video, we'll actually measure those two with a multimeter.
Oh, okay.
So that's an easy way to do it if you don't want to look up the code. Or there's any number of utilities out there on the web where you can pick the colors of the stripes, how many stripes, and it will tell you exactly what the resistance is.
Got it. Okay, cool.
Yeah.
So we did it.
You did it. You're a programmer now.
I did. Well, you hit the buttons, but I just.
Sorry. Wait. Let's make it so you're a programmer. What do we want to change?
Can I change the?
Yeah, you need to become a programmer today.
What do I do? I could just change the milliseconds.
Yep.
So I could just change this to like, I don't know, something silly like 300.
Yeah. Honestly, I'm trying to think of what that will do. I don't know. I think it might make it more jumpy.
Oh, look at that.
More
Okay.
jumpy.
Because you could see it's stepping.
Yep.
it's stepping in
Up.
voltage up and down, or not voltage, amperage? What's going through?
The time is stretching between its change in frequency.
Frequency, okay, got it.
But now it seems like it stopped, so maybe it doesn't like that for some reason. But that's all the fun that we have in trying to figure this stuff out. Oh, there it goes. It's going back down.
Yeah, it's working. Oh, because I think it just stays up. I think it just like hits a brightness and it stays that for a while.
Yeah, it reaches max brightness
And
quick.
we're not seeing that.
Yeah.
Cool. We did it.
We did it. You are a programmer.
I've leveled up.
You can write that on your resume.
That's really good job advice.
Good luck.
And so this is just step one. We wanted to talk high level about sort of some of the different products at Microcenter, obviously.
Yep.
But we also just wanted to talk about sort of getting into this and how easy it is. Like this is pretty easy.
It is.
Actually, this is easier having you talk to me about it versus when I tried doing this on my own and like going to a YouTube video, going to a guide, going to this. It's kind of nice having someone to just walk me through it.
Yeah.
So I think the whole idea here is we're going to do a series of these. Andy's going to walk us through a couple of different simple projects, and then I want to ramp up. Like I want to start doing some crazy stuff, and we're going to get there, I think, pretty soon. Cool. All right. What do you think?
I want to shout out to Mr. Baumgartner, I think he was, back in high school, for teaching me electronics. Mr. B.
It's paid off, clearly.
It's paid off. I get to play with Arduinos. No, I think the big takeaway is it's inexpensive. I mean, you could do all this for under $10, honestly. All this and more. And at the end of the day, it's not scary. This video series that we're doing, why are we doing it now? Because we want to remind people. I mean, there's plenty of videos out there on how to do this stuff. We're trying to give you a little bit of a fresh look or a current look at it, and make it so that you are not intimidated by putting a couple of wires together.
Yeah.
Worst thing you're going to do is reverse it and burn an LED, which costs 0.01 cents or something.
Yeah, I know. We got plenty of these, right?
All over the place. Yep.
Awesome. Cool. Well, stay tuned for more, and make sure you stop by your local Micro Center. Check out Electro Bytes hitting stores soon.
Soon.
And we'll keep you posted on when that's coming. And do you want to sing us off on a Micro Center studio? 1, 2, 3. Micro Center Studios.
Close.
I actually forgot how the tune went.
You did.
No.
Pennsylvania Lottery. I think that should be it for like the Micro Center Studios. Micro Center Studios.